Okay, I'm sure we'll get some image and some audio, so.
I have to accept it.
Yeah, great. So it's great to have you all here. Very exciting, and having joined the. So this is actually the IED acoustics theme seminar, which Francesco is leading.
Okay, that's a more official. Okay, yeah.
Yeah, so it's actually a very it's quite an official ID-wide thing, although we sadly don't have currently people joining from other themes, but we are working towards this, so we hope that in future we will have more people from other groups joining. So yeah, Francesco and Andrew, who is not currently present as theme leads, were very kind to host Silviya while she's here for a research visit to our lab in Paris. Silviya actually got in touch regarding our SSID work and our protocols and study, and this is probably she learned about us through Gunnar. And maybe might be also an opportunity to mention the Nordic Soundscape Research Network that Silviya is leading on parts of Finland, or
Yeah, I'm in Finland, but
yeah,
coordinator is Soundscape from Norwegian Institute of Environmental Studies.
That's the one you joined.
Yes.
Yeah. Okay,
Yes.
Yeah. So it's a great network on behalf to protagonists here, Gunnar and Silviya. We had a lecture from Gunnar 2 months ago in one of these meetings, and now we are hosting Silviya. So Silviya is UCL alumna, so she's quite home here. She it was your master's
yes.
that you completed, not at Bartlett, but at UCL.
At Bartlett.
Yes, at Bartlett, of course. Sorry. Yeah, but not this year, but yeah. And currently, Silviya is working at the University of Helsinki at an ERC project for GREENTRAVEL. And I think our groups share a lot of common methodologies and approaches, although they are not focused on sound as much as we are. They're looking more at other, holistic environment. So I think it would be very interesting for all of those who are interested in context, non-auditory factors for sound and such. Yeah, so without further ado, Silviya, please.
Thank you. It's a very nice introduction. I can skip the first 2 slides already. I'm joking. But thank you so much. It's been great already whole week to be here, and Gunnar and Tin and Francesco welcomed me really well. And I will talk about, so I'm as I say, a postdoc researcher at the Digital Geography Lab in the Department of Geosciences and Geography. I'm also part of the Helsinki Institute of Sustainability Science. And before that, I was part of the Faculty of Biological and Environmental Sciences. So my background is basically broadly in environmental sciences. I did the master's here in UCL in environmental sustainable development, and then the PhD in urban ecology. And I do a lot with GIS and spatial analysis. So now I moved to the working with geoinformatics. So it's generally quite broad. And I do, maybe I should put this a little bit like this. So our digital geography lab is quite big, like yours here. So our professor and leader is Professor Tuuli Toivonen. She's a professor in geoinformatics. And all of the researchers, so we have more senior from associate professors to PhDs and masters and research assistants. So we're a very large group. And actually the group is largely focused on GIS and spatial analysis and geoinformatics, but also the use of big data. So we use a lot of social media data. We also use mobile phone data directly from mobile phone providers like you have here. And we also use different kinds of AI and automated methods to study human use and movement in the cities, but also things like nature conservation. So basically it's quite broad themes. We also use different kinds of data sources like Google Street View images and so on. So in the whole lab, however, I'm the only one who works with health and particularly more of mental health rather than physical health and well-being, as well as with soundscape and acoustics. So it's really a kind of a smaller part of the whole group, but that's the good thing because then we can combine methods and find out research questions in different ways. And then, so I decided to present today a couple of the more interesting things and working on and how I use sound in the or have used sound. So the first one is a project that already finished. It was a project called Smarter Greener Cities and was funded by Norfolk. So it had several northern universities, but as well as in New York, the Urban Systems Lab. And in that project, we actually, I'll admit her, in that project, we had yeah. So one of the first things, because I largely have done before participatory mapping. So I use public participation GIS, basically asking urban residents to map how they value urban space, where they go, for what reasons, and to connect and overlay this data with different kinds of biodiversity of ecological or movement data. So basically we know where people are, and then we can know what is the environmental quality of these areas and so on, as an example. So one of my main ideas was to actually, for the first part of this, to test, the maps are a bit small, to test, can people map sound? So we very often have can you map areas you use or your favorite place to visit for recreation is very common and probably know. So we asked in this paper in a neighborhood, 2 neighborhoods in Helsinki, for people to map how they value different kinds of urban green spaces, whether, for example, aesthetic, biodiversity, outdoor. So we also had a question about restorative sounds and urban life. And then we asked them to map their pleasant sounds and unpleasant sounds they experience using this broad categories of natural, human, mixed. And we also had 2 categories that came out from the people's responses on quietness and technological. And then there was, natural, human, and technological, predefined, and mixed and quietness came out from the responses. And then they also were asked to say if the sound a little bit on the temporality, so if it's continuous or they can hear continuously or sometimes or how often, and on its overall pleasantness. And then what was interesting, this was really a methodological paper actually. So what was interesting, the first thing we realized, because it's a very common in participatory mapping studies to do kind of distance from home measurement. So how far are things located? It's really about accessibility to pleasant environment, basically. So we asked them, and we've realized that compared to all the other values, actually people were able to, you see on this graph, this is in meter, the distance, to map sounds that are only within close to their home environment, which speaks about the cognitive map and how people are able to remember and kind of really be able to contextualize how they experience sound, that it needs to be closer to home. So they can really map areas that are really far away and say, okay, I really like this park on the other side of the city, but they would never do that for sounds, which was really interesting. And then we did kind of a, we did some overlay. So we did hotspot analysis. We kind of looked at where the sounds are located. So like where the hotspots are, for example, biodiversity or restorative sounds or unpleasant sounds and so on. And then at the end, we do this kind of like overlap analysis, and where we realized that the idea was that even if you have an area that has high landscape quality, and this is really about the interplay between the soundscape and the landscape. So even if you have an area that is perceived as a soundscape quality, if people experience unpleasant sounds, that really kind of decreases the overall experience, and it has large implications for urban planning. So the idea is that we actually really identify hotspots of this kind of like potential for conflict, as we call it, where you have a high overlap between landscape values and also unpleasant sounds. So we can identify those areas. And what was interesting, we discussed that in the paper, is that when you look at urban green infrastructure, we often talk about like remnant green spaces. So basically that exist for a very long time, old forests and things like that. Then there is hybrid ones that are mixed between newly developed or like a really modified area for recreation, and new types of green, like completely new built parks, green walls, green roofs. So all these new types of infrastructure, they were actually the areas that we saw most kind of conflict. So that was also quite interesting to look at. And then we also did some real in situ experiments. So I think this will be probably most interesting for you, and this is where I used actually the soundscape quality, affective quality scale. So we had, this was done during COVID times, by the way, so we had lower responsive participants that were, but we put it off. So we had a 45, we had good statistical significance, so it worked out well. So in this case, we studied the, and also actually Gunnar is a co-author of that paper as well, so he's been helping out. So we studied the how different landscape and soundscape quality can promote physiological and psychological restoration in nearby nature. And what we really studied here is that the residents of one neighborhood, how they experience the environment in their really nearby in their neighborhood. So we took the people who live there in the places that they're often visited, so in the map, and we had 3 types of a park, a forest, a beach, very, very kind of a normal way to compare different types of parks. And we used this to study the stress response. We used electrodermal activity by this smart ring, which is called mood metric. So it actually measures is how the autonomic nervous system work. So basically it shows arousal of the nervous system. And that has to be understood that arousal can be positive and negative. So it can be also a positive stress. But the idea is that whatever you experience throughout your day, whether it's a positive experience like being out with friends or going out, you still need time to recover. So providing these places where you can recover from everyday stress is really important. And we studied what were actually the factors. This is a really complicated, honestly, it's a really complicated thing to do because there are so many factors that interact with each other, not only the landscape, the visual and the audio, but also all other stuff like weather. So we decided to map everything, or as much as we can. So I'll just go back. We walked through this walk, which was predefined walk, and we randomized the people. We randomized the order of the stops, and these people stopped in this walk and actually could sit down for 5 minutes. So they walk and walk and walk, and then they arrive. And they sit for 5 minutes and they just observe, they listen and they hear without doing anything. And after the 5 minutes, we start filling in the questionnaire. And during that 5 minutes, we take the recordings, the binaural recordings, and we also take the all the other measurements that we have. So we had the environmental assessment as well as physiological and ecological data. And we measured, for example, We had observers, so we measured the number of people that are in that area, so how many people there are, what they're doing. If there's even like we measured the number of wildlife that experience. We measured temperature, air humidity, wind speed, wind direction, air pollution. And we also measured, we wanted to study the never naturalist. So from the acoustic, we actually used the normalized difference soundscape figures to show a ratio between the anthropophonic and also the biophonic sounds. And then we took 180 degrees of photos around, so they were instructed to look in one place, but they were to 180 degrees, from which we measured level of naturalness, basically a ratio between built and natural environment. So we used the phonetic segmentation algorithm for that to calculate that, excluding people and sky. So basically it's these two measures showing us the same thing. And we also had the this personal characteristics in the question, so age, gender, education, how stressed people perceive to be, as well as an inclusion of nature itself scales. So this is nature connectedness, basically. There are many scales on nature connectedness, but this one I think works quite well when you have to fill in something fast. We use also the perceived landscapes quality, the perceived environmental aesthetic quality scale, overall visual pleasantness, as well as the sound source perceived dominance, the perceived sound effect. I'm not sure if this is correct. Is this correct?
I said yes.
Yeah.
Yes.
Okay, good. And the soundscape appropriateness and the overall soundscape pleasantness. So we kind of combine all of this. And the thing is that we did GeoMM analysis, and then it was quite difficult because when you have lots of factors, a lot of environmental and human psychological factors, when you put them in the model, it's kind of like the model collapse. It doesn't make a difference so much. So we had to like play around a little bit and find the best way how to do that. So we did two models, and one is that is between place, where the place, whether it's park, forest, or park, is in the model, and the other one is when you take out the different, when you take out the place and you just have the different variables, and then you see, regardless of place, what makes sense and what affects stress. So this is from the first model, and it actually showed that, as expected, according to our hypothesis, the changes from mean ROS, that's a restoration outcome scale. So basically it's the psychological counterpart of the physiological response, which is the electrodermal activity. So how you read that is that this is, so the higher is on the scale from ROS, the psychological, the more restorative it is. And here is the other way around. Actually, the lower the stress level is, the more restorative it is. And they both showed us the way of the same thing. However, it showed us differences between the psychological and the physiological. So in this case, the beach was psychologically most restorative, but in terms of the physiologically, actually the forest was the most restorative. So this speaks about that different natural environment can really affect different psychophysiological responses, and it's the importance of diversity in general. We also found a really interesting, that was not actually like statistically significant, but I believe it's because the sample was too small. So we found that almost like really borderline significant, that within 3 minutes, you can see actually restoration, especially in the forest. So that's really actual response to previous laboratory effects, where you can see very fast and rapid short-term recovery. So it was a nice surprising result. And this is the other model where I was telling you. So this is regardless of place, that you can have like what factors were found to be affecting psychological and physiological restoration. And that's, yeah, we found that the quality matters as we could expect, but of course, actually there are not many studies that look at that, but perceived landscape and the soundscape quality matters. And also NDSI, so was the only significant factor affecting both, which was quite interesting. So the sound was the only effect, the one that affected both. But this was also mediated by the presence of other people. So it was sorry, there is a mistake. It was moderated by the presence of other people. So it's it shows the potential for people to act as important moderators of frustration. So basically, when there are some people, not too many, which is the golden thing of what is the balance of having not too many to be crowded. When there's some amount of people, people perceive sounds as more pleasant. I guess this is an interaction between feeling of safety and perception of sound, but this was interesting. We also found that, as we call it, the stress baggage before entering the green space is important. So basically, it's not only, many of these studies actually look at things like why you are in a space, you recreate, you sit down and enjoy. But it's actually what really shows is that on the way going to a place, it really has a significant and important, it's an important factor here. So for in this case, like why people were walking, their daily stress level, so when they entered, how was their day, and the self-reported mental health. So you cannot study this as an isolation, which is also talk. So we have to talk about the whole expo zone. So this is about this study. Do you want to, shall I just go on, or do you want to ask any questions on this?
Maybe it's useful to ask questions.
Yes.
It's relevant to some.
Yes, yes, please do. Because I'm changing completely the study now,
Okay,
so yeah.
Can you say more about how you measure the stress?
Yes.
Yeah, and also what's the baseline for stress?
So we measure the stress with this ring. And so this ring is actually, it's a smart ring that we gave to participants to, this particular device needs 12 hours of calibration, and it measures your own individual baseline, basically. So we had a training session, and then we had the walk on the next day. We met with the people, they signed all the forms, we gave them instruction, we set up the rings, we set up the app because it works with a mobile phone app. And then they just take it home, they sleep with it, they come the next day. And that is really important because when they sleep with it and they go with their everyday life, you can get this baseline based on their individual low and their individual high. And that's how it, and so when they came to the participant, to the study, we had that baseline basically. But in like other devices, like back, they don't need that calibration. So specifically this device needed calibration, but other devices may not need calibration. They start straight away too.
So why other devices don't need the calibration? Because that's quite important to have this average.
Well, it's way faster. I think for Biopack it's like 2 minutes, 1 minute that you need.
Yeah, I mean, this sounds very impractical, but then again, it gives really a lot of weight to data. Like if you like, it sounds like you really know your participant and know the individual.
I think this is great, and why it's great is also it reduces bias. The ring is a bit bulky. I don't know if you have it here. It's a bit bulky, so actually when participants wear it, they get used to it. They don't notice it on the next day. So it's really like.
Do you need to give them instructions not to do like very heavy business?
No, it's not sensitive to. They can do everything. The only instruction is not to wash it because it's not waterproof, so they can't shower with it. But everything else is completely fine.
So when they have a shower, they can take it out.
Yes,
and put it
yeah. It's
So this calibration is essential, I think, for all devices.
Yeah, but as I say, in the laboratory devices, it's quite fast. It's like for 1 minute or straight.
Maybe it's a different kind of
question. Yeah.
So other question is, so for stress, maybe some people's recovery and range is different from others.
Yeah.
Do you have this individual?
Yeah, so basically when you when you look at this, for example, how it works is that how we did it, there is different ways to do it, but in this particularly, it has its, so it takes the skin conductors SCL, so it's like from the mean. So basically, when you know the individual mean, you calculate the deviation from the mean or average per, in this is average for all individuals, basically. But that's the point, because even it doesn't matter what is the range. It's when you have the baseline that is kind of normalized, then you can have this deviation from the mean, which makes, in a
So
sense,
it's
a
assumption
good level.
that, for example, if I change the unit of 10,
Yeah,
you also change the unit of 10. My average is 50, your average is mean is 100.
yes.
So is my time change same as your time change? Or
So, so in this specific device had it calculates an index from 0 to 100. And basically it calculates then for a mean that is 50 for everyone, but it's still that 50 mine, the raw data is different from yours, but at the end what you use is this 50, which is different. Yes,
okay.
so it normalizes it.
normalized,
Yeah.
then you assume everyone's time would be same.
Yeah, or everyone 50 is the same, and then the deviation is kind of,
Deviation, okay.
from that.
Yeah.
So, but that's there's it's a huge thing, this like individual, and you have to, like, there is many things that affect this, like it varies a lot, like even gender affects this. So we took it, in this case it wasn't, but like how it like the EDA specifically, it's really dependent on gender, it can be dependent on race, on the climate. That's why, for example, we took humidity and we put it in the model, because if it's a warmer day it will affect. So there's a lot of things that but
Yeah,
as soon as you control for them, it's fine.
Yeah, that's affecting the mean.
Yes.
But maybe some people.
The raw values, even the raw
Yeah,
values.
raw values.
Yeah.
Because maybe some people are more stress resistant, so time doesn't matter for me. But maybe time is very significant for other people. That's a kind of assumption, or
I'm not sure what you mean, because that's the point, that even if
You just the mean,
yeah.
but what about the extremes? Is a scale of 50 from 50 to 100? Does it mean
so for
for everyone
example,
the same?
in last 12 hours,
Yeah.
my stress level changed from 0
Yeah.
to 100. Mean is 50. But yours is changed from 49 to 51, also meaning 50.
Yes,
So
yes,
that's my stress level changed a lot.
yeah. And that's fine. But the idea here is that how can I explain this? So the idea here is that you take this just for the calibration. So basically, it doesn't matter how much it fluctuates. It takes, for a calibration, it takes your highest and your lowest measurement at any time. So the fluctuation is not that important. So it takes the highest and the lowest, and then it calculates the mean from the highest and the lowest.
Could be that during that period of calibration, somebody experienced higher, more extreme environments than the other person, right? So then it can, for somebody, this will then go above 100.
No, it
Or is it
won't.
peak?
No. No, because that's like the range that is, but that's specifically for their index. So the raw values is different. So there are, but the thing is that this company specifically, like they have this English that they have the proprietary algorithm, so they don't share exactly how they calculate this, but what is the basic methodology. What we know is that they take the highest and the lowest, and they do an individual calibration, but they don't share the exact formula of how they do it. So the ideal thing is that you take just the raw values when you work with those, like we do in the lab. But for real like convenience, this works very well, because you get a mean value based on this. You can also work with raw values, but in this specific ring, they were just 1 signal per minute, which was two cores.
So
So
is that the maximum sampling rate you have, or?
for this, I think for the new one is, do you know how much?
It's four, it's you can use the raw data and the new one. So
Yeah,
it's,
Yeah. So they have a newer version that you can use the raw data, and it's,
And you can still have the option, I think, to use the calibration, because that's
Yeah.
really useful.
Yeah.
Because it takes so much longer period. The alternative would be to make the baseline on site, right? And then there could be influences. Perhaps there's stress just when they're taking the baseline, so that's also.
then you have to stress individuals before they.
Yeah.
Come in.
So I suppose the basic question is, what's the just noticeable difference in terms of
Yeah.
stress level? Do you
Yeah.
have that straight?
Yeah, that's all that's statistical significant noticeable difference between the mean. So basically, if you see here, that's the mean, and then it's like statistical
yeah,
difference.
that's
and
statistical difference, but does it matter? It's really physiologically just noticeable difference. Maybe
Yeah.
heart rate change 1 doesn't matter, 5 will be noticeable and 10 will be significant. So do you have that kind of?
We didn't work with heart rate, we worked
No, I
just
mean,
with
it's
skin,
present, yeah,
skin
yeah.
conductance.
Yeah, no, the same thing.
Yeah.
So for certain change, although it's a significantly statistically, but doesn't matter.
You mean if if people can feel it themselves?
Yes, that's right. Yeah.
And that's why we have the restoration outcome scale, which is the perception of how people, so it offers different statements of how people feel to be restored after this. So we triangulate that and we see that's why we had the physiological, because sometimes you may not feel the physiological. Most important is that when you're alert, you may not feel it. So you may think that I'm really calm, but actually it's like this. So basically, that's why it's good to have the psychological skills in addition to that, to know that if people really felt restored.
Mhm.
And that's how we because the physiological, I don't think that people can feel always.
So
if they are.
you calibrate physiological one with psychological one.
In a
So
sense, you could
yeah.
combine them to be more sure that it's actually both are. It makes
Yeah.
sense what you were just saying.
Yeah, I remember there was a big discussion years ago when people start to do physiological thing. Psychologists said if you or come back to psychology, why you do physiology? So
My answer, it's all part of the same thing. So they are really integrated and they affect each other so well. So basically the psychological, the cognitive kind of like part of it affects also the physiological and vice versa. So it's really important to combine those, I think.
yes, this is also some work we have done, and I think this is quite a fundamental question. We also like to have an answer for.
Yeah.
So maybe fundamentally, if we could find out, say, okay, this change of 10% of skin conductivity or whatever will make your health really bad, but you can't feel it. Therefore, we tell you more about psychology. In addition to your psychology, you feel I'm fine, I'm comfortable, but the psychology tell you no, your health will be affected. I think maybe that's quite more powerful rather than just calibrate through psychology. Say you feel bad, therefore improve. You feel bad.
Yeah, it's like what definitely.
It is. I think it's very, very difficult to find out this kind of threshold for physiological indicator.
And
we can always know what's different, but we don't know. So what? What does it mean?
It's very difficult because it's also very it's very so individual also, and it also depends. Like it's more like I think upper and down threshold rather than absolute value or mean value, because it depends like what you are just saying. So like if you have like a windows of, we can say it like a windows of tolerance to stress. So you have an upper level and it's very normal that it fluctuates. But when people are for a very long time feeling the stress or they have a mental health issues or whatever, actually this window shrinks or it can expand. So if it expanded and you have like instauration and increased capacity in general, like nature can do, So basically you have more room for maneuver. And when it's really low, it's very easy that you go so much up. Then you have like things like anxiety or panic attacks or all of this, because, and this thing it fluctuates throughout people's life. So it's very difficult to give him, but it's more like to make this window higher, to make people more resilient, to have cognitive breaks. And that's, I think, and what I think is here important is I stress that like the forest was physiologically more restorative, but the beach psychologically. So they have different mechanisms, and if you study just in one way, you'll say, okay, forest is the best, and that's not really how it is. So it's
let me twist. Now say physiologically it's different from
psychologically, yeah.
So which one is correct?
They're not correct. They're both correct.
But when we design it,
Yeah.
Should we design according to psychology or?
Yeah, I think that's what we say in this. No, I think what we say here, yes or no. I think the point is that you provide areas like a diversity of different types of environments, and also environments that have multifunctionality. So basically with this multifunctionality, you can tap into the different demands and different state of people, basically. So you have people would have access to green parks, forested areas, treed vegetation, water areas. So that's the whole idea, that we have more difference and diversity of that, so you can tap into those benefits, basically. That's how I see it.
I would say for design, you need to have multi-dimensional targets.
Yeah,
Rather than single. I don't know. Francesco, raise your hand.
No, I had another question on this because it's super interesting. So am I right in saying, have I understood correctly, that basically in the seaside, the beach one was the only one with blue features, with water features? So the forest and the park did not have.
Yes.
Okay. And did you have the chance to look into the acoustic counterpart of this, like whether maybe the sound environment is driving some of?
Yes. So, but only through this, like in this NDSI, the normalized different soundscape index.
Yeah.
So basically, and also through the perceived quality scales.
Okay.
So in our in the paper, in the supplementary materials, there is all the parameters and all the values. I think the beach was the highest. So the psychological, the one that had the highest perceived landscape quality was the beach, and it got the highest psychological effect. So that may explain that.
Also, I wonder about the nature connectedness, right? In the how you measure that you have already acceptance, like for example, forests are already accepted as a more nature connected. Let's take the data, or depends on their replies. How you feel in that place to the.
It wasn't context specific, it was general. So it was part of the general personal characters, how in general you feel nature. So it's this scale that shows that I'm part of, I feel like I'm part of nature in general. So it wasn't, we didn't ask for every place they stopped, just once at the beginning.
Yeah.
Yeah, and we found it to be.
In beginning and the end of the.
No, just in the beginning, because that, we didn't study the effect of nature connectors, like the change.
Country mouse or city mouse.
Yeah, it's a bit like urban or nature oriented. So basically that, and that had an effect. So
Yeah.
Yes.
I had another question on one of the first slides. The one about mapping, the particular mapping.
This one? No, this one?
Here. So I don't know if I missed it, but were you able, so my understanding is that, again, mapping is possible for landscape values, is possible for something that is further from you, while for sound, you are only able or only willing to map soundscapes that are very close to you.
That's what happened. That's what the participants did. Yes.
So were you able, I don't know if I missed that, to establish some kind of radius, like where is this limit?
Yes, so this is in meter, so, but it's the mean. So this, sorry, I didn't put it. This is the mean meters. So for unpleasant farms is 582 meters from home as a mean value. And then for the upper one is one neighborhood, the down one is another neighborhood. So the pattern was absolutely the same, as you can see. And then the pleasant sound was further away from the so almost twice further away from the unpleasant. So this is 1,000 meters from the home. And then for both the patterns, it's absolutely the same. Pleasant sound 676 from the second entry, about 400 from
Because I think this, I mean, this is super fascinating in terms of design, like, you know, I remember there is an equivalent for this, I think in Sweden, like there was legislation where for access to green parks, any resident in Stockholm or should be able to reach to have 1 hectare of green space
within 300 meters.
300
Yeah.
meters, I think. But so if we manage to basically get a similar number for
Yeah.
Soundscape, and so is this closer to us? Is this smaller than 300 meters or more than 300 meters?
Mhm.
Can we design toward
Mm-hmm.
that kind of target in terms of Soundscape planning?
Mm-hmm.
Like to have everyone should have a pleasant soundscape within 500 meters, or you know, for unpleasantness, also in terms of amount of population that you affect.
Mm-hmm.
You can say, okay, this, when it comes to a new source that is an annoying one, you could say it doesn't matter beyond that radius. So I don't know, I think I haven't tried this in very much detail, but I think these numbers, there is a lot of interesting material for planning.
If you can dig deeper.
If you can, yeah, implement those numbers and make those numbers universal.
Mm-hmm.
Because this is only 2 cases.
And also you have to take the sound source into consideration, because like especially for the pleasant human sounds, it will be a bit difficult to integrate into urban planning, but they can, I don't know, can you? Like, I don't know, how can you?
I don't know, but I'm just thinking about the narrative of this, someone who is planning, doing soundscape strategy or whatever. The moment you have those numbers, you can implement design and say, look, if you claim that this pleasant soundscape is for the benefit of these people, but we actually know that after 600 meters, you lose that benefit. So
that's really good. So this needs further validation. So if there is a way to test it, so it's basically a participatory mapping software that we use always, and you can ask many.
I think the closest I can think of is the material by Antonella Ravi. I don't know, I mean, she has been mapping quietness in particular.
Yeah.
And I don't know
My
what
goodness.
has information about where the people are residents, like the, I don't know, yeah. Just it's super interesting. Thank you.
Yeah, like this, what it says is you can have a fountain every 1 kilometer, but if you have bad sound, after 800 meters, doesn't matter anymore. But I think maybe the reason for this is in your case study sites, positive sound, pleasant sound is more rare. Therefore, people remember, if you don't have one pleasant sound in whole city, everyone will remember it. They're like maybe 10 kilometers. But if you have, so maybe it's useful to also see the distribution, if they are equally distributed.
Yeah. We didn't go into so much detail here because it was really like overlapping the different things, but there were quite a lot of pleasant sounds, actually natural sounds, especially because many of these areas are very close to very green spaces.
Yeah.
So there were quite a lot, and in one of the areas was also about this like vibrancy quite a lot. So there were quite a few mappings, way less mappings for unpleasant.
Yeah.
Way
So
less.
suppose if you apply it to different cities, the distribution
May
should
change.
be- if distribution change, this will also change. But
Maybe.
if distribution is similar to what your case study,
Then that will be interesting. Yeah, definitely. Interesting to study, yeah.
Because that's really fascinating. But what question would you ask about the distance? So
Oh, we didn't ask about the distance. We know where people live, so we asked where people live, and then we calculate equation distance from the point they mapped. So we calculate the
Oh,
distance.
So
Yeah.
that's a pleasant sound. That's a
Yes.
pleasant sound.
Yeah.
Okay, yeah.
So they put it on the location on the map, and they put the location where they live, and then we can calculate the distance based on
So
that.
for this one, how many people did you survey?
No, this is different. 500?
500.
Yeah.
Okay. Yeah.
460 something. I don't remember.
Do you feel that's big enough, or you wish
For this two neighborhood, yes, but not for this is not a city scale, and it's not a multi-city. So
okay.
definitely this is two neighborhoods.
So how
Of Helsinki.
what's the kind of area size?
Well, this is 500 meters.
It's about 500.
This is 500 meters. So
Ah,
you can imagine the
okay.
area.
Yeah.
They're both in Helsinki, these two neighborhoods.
Yeah.
But city-wide, it will make like for the whole city, it will make sense to do this distance analysis.
Yeah.
And then I have another study I can show you where we have more cities, but I didn't do that especially. But
So how did you find these people?
we do postal. There is many ways that you can. So in this case, we did postal invitation using random sampling. So we take the registry data from postal code, and then we send out, in this case, 2,000 invitations, and then you get random sampling participants from people who live in that area.
Oh, you sent 2,000, you got 500.
Yes.
No.
No, 2,000 per area, sorry, 2,000 per area. So it's about 10%, 10-14%, yeah, which is normal.
Yeah.
10-15%, we find it quite normal, I think. Yeah. And in the other study that I'll show you, use the panel. And you can also, I think this is quite, but this is, I think quite general. If you target specific area for a whole city, it's a bit too expensive.
I think that's really, maybe we should do an international kind of comparative study.
Yeah.
With different urban structure.
Yeah.
Maybe in China, Turkey, and other kind of places.
Yeah.
High density city and low density city, to see whether this value will change, especially present sound unpleasant. This is very fascinating.
Yes, and definitely we have a software called Maptioner. So it's a software you pay a license for, and then in the license you can just do as many cities as you have, and it's quite easy to use. And you can do different. You can also add audio, which is because I asked them to, but you can they can also add upload files. So people may, if they like, upload.
So how do people get response to you? They just scan a barcode?
No, it's an online survey.
Online survey.
Yeah.
They can also upload audio if they want. Video, audio.
Yeah. They can upload audio, video, files, photos, anything.
Yeah.
We can use it.
Yeah, maybe one thing we should do.
Yeah, definitely.
Is the international comparison.
I would be happy to, because I'm a participatory mapping. I'm also like expert. That's my core thing. So this is not many people have mapped sounds. Usually noise, or quiet areas in sounds, but not really like the properties of sounds or like the quality of the soundscape environment. So it's quite useful, I think.
Yeah. Yeah, we should keep this in mind.
Yes, definitely. And I'll send you the link so you can see the software and also this paper.
Yeah, that's great.
Show him. One more
Yeah,
question.
just a
Okay.
quick one.
Yeah,
Like,
sure.
You mentioned positive stress and negative stress.
Yeah.
Was that a purely observation of the statistic, or does it have an implication between the two? Like, does that imply how I feel differently?
No, it's purely how physiology works. It doesn't have anything to do with this. It's how it's basically arousal. So arousal can be positive and negative.
Basically positive emotion, quote unquote.
Yeah, it's like positive arousal is generally very often
because you
interact.
because
Yeah.
it's usually implied bad.
Yeah, it is. And that's the whole point, that it's implied as bad, but it's actually what skin conductance measure is arousal. It's not stress.
Okay, so.
So the thing is that
What do you mean when you say positive stress, or does that?
that implies, so for example, humans are this arousal, and you see like peaks when people are in a social interaction. That's a very common thing.
More like motivated?
So when you're happy, we're very social creatures. So
Yeah.
basically, so that's why in this case, we didn't allow people to talk to each other, because once they start to talk to each other, it's like, or if they see someone, so if you feel happy,
It's more like
on your wedding, probably everyone had like really high around the wedding. So it's like really,
maybe it's like a drive or a motivation of doing something that you can't do.
it's probably, yeah, it's related to emotion probably quite a lot. I am not that deep into like definitely, but
Soundscape's increase of
yeah,
value and
it's just that the
decrease.
reason for it is positive emotion basically, or positive interaction, rather than cognitive load or being busy or things like that. So it's more like the reason for it is positive than. But
I
Yeah.
wanna ask you the air data.
which one?
Air pollution data. Because you mentioned in the first talk, as I remember, you took from the open data from a map or the government, or you measure point of place.
For the GPS track, or
Yeah, I think so. In one.
this one?
Before, I think so.
This one?
Yeah. Did you measure the air pollution?
Yes,
Yeah, okay.
we had a portable device.
Yeah.
Yeah, we had a mobile, and all of these. So we had all of these, like so you know that there are different ways here. So we had PM 2.5, PM 10, and as well as NO2 and ROC. So we had all of these. So all of these were put into the model.
Mhm.
So we had a small device that where people were carrying with, as well as it measures humidity, wind, and temperature we took from normal meteorological data. So that was something.
Okay, perfect. Also, I wonder about the age-based data, because when I check your article in the next one, you gather a lot of different age data from them. Is there any difference from their reply? Because there's a huge
Probably you mean this mapping one.
yeah, mapping one. You have 18 to 29 and also the 65 plus groups.
Yes, yes.
It's
Yeah.
really impressive, I think. It's not easy to get it.
Yeah, but because of the random sampling with that, but it's still like it's not that, well, it was like representative for the general distribution population in these scenarios, but it's still usually in this online service, it's more biased towards, like it's older people are more difficult to get. So it's not perfect. But it's representative of the population. So, but we didn't study differences between how people do that. I've done that previously, but not how age affects the perception or things like that. So it was more like where things are distributed and general spatial patterns. You're welcome. Anything else? I think that's more the things that are really relevant. Yeah, great, and I'm very happy that you asked so many questions, and thanks for the scales, because I used the effective quality scale, so I wasn't really familiar with that. So I've used quite a lot of the preference and visual aesthetics, but so it was quite useful, and great job to you and your lab that you were able to help that, and I could use them. So now I move out to this, which is our ERC project that I'm working on, and that's what I'm currently working on. So it's GREENTRAVEL and measuring, it's called, it's basically measuring well-being impacts to big data. So if you remember how I ended this was that it's not only about what people feel and experience once they are being in a place, but also when they are moving to a place and when they get there. So this really kind of gave the idea that we actually know very little about health and effects and well-being of street greenery during everyday travel. So this project is a bit less, we study a bit less soundscape. It's more like multisensory and transportation. But the idea is that we study street greenery and the effects of it, what it matters, why does it matter, why in a hurry, cycling or walking. So it's about active travel. Do we notice nature the same way? Does it has to be intentional to feel the effects? Do you pay attention to the sounds and to the all the other environmental factors? So it's really like this, there is very little understanding of that. And that's generally, we have several work packages. So I'm leading work package 1, which is understanding people experiences and well-being impacts. We had another one which maps urban greenery with human perspective. So trying to map using Google Street View images and other, like not only the present and absence, but also what matters to people. And we model everyday mobility patterns with transportation data. And my favorite package, which is revealing inequalities and prioritizing improvement. So basically the idea is that, of course, like with green spaces and access to green spaces and inequalities in access of green spaces, but also residential nature, there's also inequalities in travel environments. So where people go through, not everyone can cycle through really nice parks. So some people are walk. So this is important. Here again, we did the PPGIS survey. So the same GIS mapping survey with a different question. And that's in 5 cities in Europe. So Helsinki, Copenhagen, Las Palmas, Munich, and London. Here we're working with City of London. They are asking us to, especially in terms of street greenery, to provide data on that. And this was a bit different. So basically, people are asked to map where they experience pleasant and where they experience places along their daily travel routes. And then the questions were on temporality. So if it's what season, what time of the day. And also we had multisensory aspects such as aesthetic, soundscape, air quality, and weather comfort. So basically it's more all-in-one package. And then for the unpleasant. And also we have one that they can add street greenery on that. So we just finished, I don't have any results on that. So we're just starting to analyze, but I just wanted to throw it out there.
So what's the duration on this project, the RC project?
It's until 2027.
Oh, sorry.
Yeah. So I started working in this group last year. So before that, I did another postdoc in another group. So this was the one that started last year, and I joined almost at the beginning. So in this case, and why I'm here is that, but also for many things, is that one of the methods we use is a VR experiment. So we have both VR and an in-situ experiment, the VR cycling experiment. And we're trying to find out what kinds of greenery are important for human experience and well-being. We're still in the development phase. It's very difficult to pull off because there is movement. And that creates another complexity of movement. And
so what do you mean about active travel?
Cycling, walking, everything that is not car, not public transport, basically. Okay. So I see there are many people cycling here actually in the city center. So it wasn't 10 years ago, it wasn't that safe, I would say, but I'm happy to say that.
Yeah, it's better.
So, but it also means walking as part of your journey to work, for example. So you may walk to the train station or to the tube station or to the bus. You may walk to the shop, you may walk to pick up your kids from daycare. So it's all of these journeys that are not for recreation, basically.
So do you distinguish active travel for work and for leisure, or active travel.
We don't include leisure. We don't include leisure at all. So it's everything that is not leisure, basically.
It's just that you have purpose.
Yeah, you have to
work
purpose,
or
to go to work or to go to school or to shop or to something. So it's more like basically the idea is that we have to reach a destination, so you're not recreational.
Yeah.
So cycling for fun is not, or like for leisure, or it's not.
Yeah, sometimes you take kids outside.
Yeah,
not
that's
good.
no, yeah. So that makes it a bit, and then we study really what are the effects of seasonality here more. So this project is a lot about seasonality and temporality. We try to, and that's why one of the reasons why we use VR, because we want to have the same environment in the winter and the summer mode, basically. This is quickly to show you that what is the idea of the VR thing, that it's quite a complicated thing to do, because we're not using 360 videos. We are using we call them simulated environments. They are completely built in Unreal, the game engine, so they're completely done. But we are trying to do them not completely from scratch to reduce bias. So basically what we use is we use street. We have different criteria, so I won't go into detail on that, but we use a street, and basically we take the street of the skeleton of the street from OpenStreetMap, and then we created a 3D model of it. And the idea is why we have the skeleton is we know exactly where the buildings are, how long they are, how tall they are, and then we can kind of redo them basically and do different kinds of how they look like, because we want the environment to look kind of to feel normal and relatable, but not familiar. We shouldn't, so we don't have the place attachment. So you shouldn't know where the place is, but it shouldn't feel odd. And then we use different kinds of ways to do that. And then we have different assets. So basically the objects in there. So we use digital twins, and we use databases that are available. We use also 3D scanning of objects. So for example, if you wanna, the post boxes here are quite unique. So you can have an environment that is kind of like neutral, but have one or two of these post boxes, and then you'll feel like, oh, then maybe that's familiar to me. It's London. So or how like the traffic lights look like. So we do that with 3D scanning. And then we have BioPack for measuring the physiological response. And then we have the cycling, and everything goes into this Unreal Engine. So we are now in the process of data integration, data network integration, and creating the environment of how much greener we are and where. That's a very difficult decision.
So basically your street is generic street.
Yes.
But you just
Yeah,
that's
we
not
just,
very useful.
yeah. And we play with the vegetation and with the seasons and with the light, and then we control and see how.
Yeah, I mean, how generic it is? Is it kind of typical European generic, or is worldwide generic?
I think it's
Must
more
be
like European.
European
Yeah.
generic. Your elements are coming from European.
Yeah. They're from Helsinki, so it will be
Okay.
Yeah. more, definitely more European.
Yeah.
I think there will be no really tall buildings and things like
Yeah.
that, so it's more like European. But and then finally, this is my last slide. So I also do some work with ecoacoustics and multi-species justice. So this is more related to my ecology background. So for example, with nature, we have in Finland, this is where, sorry. This is where's my mouse? You can't see. This is here. You can see. This is where we were with Tim. So it's really like really north. So we have a SM4s. How many? 9. There's 24. 9 and 9.
27.
27, and then Yeah, we have about 30, and also have because our colleague has in different locations in Finland, from very north to very south, and that's purely for like bioacoustics and for species diversity, bird diversity purposes. So we have we studied the effects of forest disturbance. So basically from clear-cut forest to very biodiverse, so from low, medium to high disturbance, and we affect how does it affect species and bird diversity. So we have that we are currently analyzing, hopefully over three years period. So now but the problem is that it's also most of these acoustics and they don't work in like sub-zero conditions. So in the winter, it's very hard to keep these devices, especially some of these areas where they're really pristine, they're really inaccessible. So some of our colleagues can go with the snowmobiles to change the batteries and the carts, some cannot. So in this case, we're still testing how this can work in really cold winter conditions. And how really to get really long-term data. And the other one is experience more than human perspective on urban environment. So this is a project that our colleagues, also Jonathan Correctus, is doing. So we're doing sound walks in relation to this audiovisual dome. We have a festival in June in Turku where it's like a science exhibition basically. And we use this dome where you have inside the acoustics and also projectors from the outside that will have visuals, and then we study the effect of that on nature connection and empathy towards other species. So the first idea was that when you come in and you can see and hear how, for example, a beaver will see and hear, but it was too difficult to do in such short time. So now we're using just normal recordings that we have done, but it's still for exhibition, and so it's a really good method. So I think that was it. Do you have any other?
For the study on the left-hand side,
Mhm.
just use acoustic sensors to identify
Passive acoustics,
biodiversity or
yeah.
okay.
Passive acoustics.
Yeah.
Based on force.
Yeah. So what kind of living beings are you looking at?
Birds.
Birds.
Yeah, only birds.
No, no animal.
Yeah, no,
bear.
no, or bats. No, only birds. Yeah.
Okay.
Yeah. It's only, and they have like this, we use different indexes and to calculate diversity. But of course, it's a bit tricky as well. And also we use data from BirdNet. You probably know that, so that's quite good way, automated way to do the species diversity.
So you have a collaborator from different universities, like
Yes.
I'm sure. Are they using the same equipment?
This is the same project, which is the MAST project, enabling multi-species.
Okay. What kind of project is it? It's
Academy of Finland Strategic Council project, so it's a Finnish council.
Then you have a collaborator worldwide.
Yes, worldwide, and actually it's a really nice. I think it's a really nice project. So this is really about moving towards justice not only to humans but other species. So can we have when we do planning, and can we have the voices of other species to be included more into decision making and planning about the dominance of humans towards other creatures and how this can be changed. We work with schools, but our project is the only one that uses acoustics. The other ones are more like using with schools or with mapping or other stuff.
Yeah, for UK funding body, they always ask what's the benefit to UK. So when we involve partners in other countries, so why you involve like Monash? That's Australian university. That's all.
Monash University is in Indonesia.
Indonesia.
Yeah.
So what's the benefit to study Indonesia Jesus,
So all
because we
the-
don't have it in Finland.
So all our case studies are in Finland, and we have this kind of like a fuller case studies in this university and in this university. So we had 2 case studies that we also, but they're more like partners rather than we do the actual work only in Finland. So they're more like kind of like a knowledge exchange.
Providing the
But
experience of-
it's very true, especially with this Academy of Finland, they want that. It's unless it's another like a partner thing, but they allow you to have partners,
Okay, yeah.
which
That's
is good.
yeah. Yeah, that's very useful.
Yeah, it's very, well, the ERC is only us basically, although we have, but you know that, so
Yeah.
it's only us, but we do have like collaborators, but still it's
Yeah.
it's very us. Any other questions or?
Thank you then. Sorry.
I'm curious about the VR experiments you showed.
Yeah,
Yeah. So you said, sorry.
this one?
Yeah. So you said all the videos are generated by
Game engine, yeah, Unreal, yeah.
So that's the people active involved in the model, that you can also hear the some people which are
They won't be activating themselves, but it will be like when you get closer to something, you'll hear it better, and so we aim for that. We haven't done the acoustics yet, but they won't be so much interacting with it. It's like the idea is that it really replicates a normal situation. They have a task, they need to go to the shop, and while they're cycling to the shop, they have different kinds of exposure on the way, sound and visual. So they won't be, because you're on the bike, in a real situation, you can't do anything. So they just cycle there and get the stimuli, and that's how we. So it's like a video, but more interactive, more immersive, not more interactive.
Do you plan to have any like traffic events during that, or it's like safe?
I think it
Sure.
will be safe, because if it's not safe, the safety is the biggest factor. So it diminishes nature. Somewhere it doesn't matter if it's safety is priority. There is like an hierarchy in transportation. They call it like an hierarchy needs. So basically that's number 1.
Okay.
So if you don't get that, it's
Not safe.
No,
so super safe, just like any place on earth. You just cycle, there is no
No
cars. That's a good point, but for this reason we have to make it safe. So,
Okay.
yeah.
It's not the real game.
No.
So the speed when participants say are the same as the.
Yes, the visual. So it's synced, which is very difficult because it can create cyber sickness, lack of convergence between the movement and the video and the sound can make you really sick. So I think that will be a huge issue for us. Very huge issue. Yeah. So lots of testing. All right. Thank you very much. Thank you. Okay.
I think the discussion was very useful for us from the team.
Thank you. Yes, and you can always ask and contact me by email, and I'll be happy to. All of these.
Yeah, so I think we have the room for another half an hour.